Welcome to From Chaos to Optimization, Alaska Airlines' observability journey. Observing and ensuring the reliability of modern apps has never been more challenging. On-call and SRE teams are managing complex application and infrastructure stacks, and thousands or even millions of resources, services, and connections between them. And of course, dealing with the resulting data deluge. In this session, you'll hear from Bryce Lindsay from Alaska Airlines on how they maximize the reliability of alaskaair.com modern tech stack through a combination of problem avoidance and incident management strategies. Next slide. My name is Bashram Anant, and I lead advanced analytics product management at Sumo Logic. Bryce ensures that the alaskaair.com site is running smoothly and that any issues are detected and mitigated as quickly as possible. In addition to observability, Bryce champions service level agreements and chaos engineering to help development teams own the reliability of their systems. Our agenda for today, we'll begin with an overview of what makes observability and reliability complex for modern apps. Bryce will then take us through Alaska Air's tech stack, observability use cases, and associated data, which set the context for observability and reliability management at Alaska. Next, Bryce will also introduce us to how Alaska measures reliability through service level objectives and indicators. Finally, Bryce will talk about how Alaska manages and maximizes reliability through strategies for on-call incident resolution, and more importantly, problem avoidance through chaos engineering and optimization techniques. A quick fun stat from Gartner: by 2025, 60% of infrastructure and operations teams will implement chaos engineering and increasing system availability by 10%. So it is really great to hear from Bryce, who will literally show us a preview of the future. We'll have 5 minutes of Q&A at the end. Next slide. On to our first topic. Next slide. Why is observability and reliability so hard for modern apps? The application and infrastructure stack for many Sumo Logic customers looks like what is on this slide, with a complex mix of technologies at the infrastructure and application levels. According to Sumo Logic Global Intelligence Service, the typical Sumo Logic customer is using 26 infrastructure and platform services in the cloud. On top of that, customers like Alaska Airlines that use Kubernetes can have hundreds of clusters and deployments and thousands to millions of running pods. Connections between these applications, services, and cloud infrastructure can be infinitely complex, compounding the number of failure modes that developers need to worry about. Put together, teams are dealing with a data deluge from their apps and infrastructure, and most of the time, on-call engineers and SREs are dealing with unforeseeable, first-of-a-kind problems. So is there any hope for observability and reliability for modern apps in this setting? Thankfully, there is, and Bryce will take us through strategies you can use today. But first, Bryce will take us through his tech stack. Bryce?
Cool. Thanks, Basham. Hey, everyone. I'm Bryce Lindsay on the e-commerce SRE team. E-commerce owns all of the systems that generate revenue for the airline. So some examples would be the alaskaair.com website and our mobile apps. Speaking of which, let's talk about the tech stack. So historically, we've had the monolith that is the website running on servers and data centers. Our newer systems, over the last few years, we've been putting up into Azure in app services or Azure functions using platform as a service. And more recently, Kubernetes became an option, and we've been putting things into there. So from an observability perspective, when we just had the monolith in the data centers, it was pretty simple. We would just throw our APM on the servers and a Sumo collector, and we were set. Then along comes Azure, and we weren't able to put our APM in everything in the cloud because of pricing. So we lost a bit of observability there. It became a little more complicated. And then along comes Kubernetes, which took off really fast in popularity, and the SRE team had some trouble getting our APM in there. Fortunately, we were able to get Sumo in there pretty easy, and then Kubernetes became an option, and we had some trouble getting our APM in there, but we were able to get Sumo Logic in there easy. And fortunately, Sumo Logic has come a long way since we just used it as a log aggregator. Now has a lot of the features that our APM has. So by flipping on all the switches, the logs, metrics, and traces, we're now getting all of the information that we need in Kubernetes. So in Kubernetes, Sumo is our go-to tool. So we've got observability. How do we track the reliability? So SLOs and SLAs. So SLOs are a way of that we use to track the availability and the response times of our pages. So we have a threshold set, and if any of those dip below that threshold into the red, it's not going to call somebody at 2 a.m. and wake them up to deal with it. That's not how this works. So what will happen is the teams have signed a service level agreement that they will address the issue and get it back up into the green. So the idea is that over time, teams are making changes, and sometimes they make changes that can have a small negative impact to performance. Not necessarily enough to trigger an alert, but over time, all these little changes can add up, and you can end up with a big impact to performance. So the SLOs are in place to help teams identify when they're starting to go down, and the SLAs are in place to help them, to enable them to get things back up and performing before issues turn into incidents. Speaking of incidents, how do we handle those? And what can we do to prevent them from even happening in the first place? So the SRE team, all four of us, shield the team, the engineering teams during business hours. We'll get an alert within 10 minutes of an incident starting. We'll jump in, start looking at using our observability tools to figure out what's the guest impact, what is the problem. Once we've identified what the problem is, then we move into mitigation, which could be rolling back some code, could be rolling forward with a fix, or in the event of a vendor issue, waiting. After the incident's been mitigated, spend some time digging in to try and figure out the real root cause of the issue. And then every week we have a standing meeting where we review any incidents that have happened over the past week. And we'll talk about what went well and what sort of action items do we need to have to come out of that to either prevent this issue from happening again or to reduce the time it takes to mitigate it. So here's a couple of examples of some incidents. Depending on what the problem is, that determines which tool set we tend to use. So for the first example, our seat map service was unavailable. This would have impacted guests who were going through the website and they picked their flight, they're going to book or check out. You get to your favorite part where you get to pick your seat on the plane, and you get a little message that says that it's not available. So we were digging into the tools, found a few things that were on fire. The one that jumped out was the SNAT exhaustion errors. The way to mitigate that was to scale out and add more connections. So that worked. And then afterwards, the team identified that they weren't using HTTP client properly. Instead of using it as a singleton, they were creating a new instance for every request, and that just burned through all the connections and caused problems. Second example was a Kubernetes issue with our flight search service. We were getting alerts that pods were restarting. We went into the Explore tab, drilled down through some of the dashboards, and identified that there was some memory issue. So then we use the global intelligence dashboards to figure out what the recommended values were, plug those in, redeployed, and everything was good. I'll talk more about global intelligence towards the end. But first, proactive stuff, chaos engineering. We noticed that there seemed to be a general lack of understanding around how our systems worked and how to support them. And there's a few reasons for that. One is that when you go on call, the system that's on fire may be a system that you've never had to deal with when it's on fire before, or you just, it doesn't go on, doesn't have problems very often. Could also be a new hire who are still learning what systems they own. Some systems also change ownership as we have reorgs. And so a team could end up owning a system that they don't even understand, they didn't even write. And then there's the challenges with moving to a new platform like Kubernetes. So chaos engineering solves all these problems. So the idea is that we break the systems or their dependencies on purpose to learn how they break, how they're impacted, and how they work. The first time we did this, we had a big event. We call those chaos game days. And we decided to start big with our homepage. So one of the experiments that we ran was taking down the Redis cache, which it had a dependency on. And we thought, oh, this is probably not going to be exciting. It's just a cache. It'll just continue running just fine. Well, it turned out that when the Redis cache goes down, the whole homepage went down. Now, we were not doing this in production. We do our chaos engineering in our lower environments. We're not that brave yet, maybe someday. But as a result of that experiment, the teams wrote up a run book that identified this is what it looks like when Redis goes down. These are the steps to mitigate that issue. So what was awesome was 3 weeks later, the Redis cache did go down in production, and the team got the alert and went straight to their run book and had the incident mitigated within 10 minutes, which was really awesome. Prior to this, it would have taken hours to have mitigated the issue. So how does a game day work? How does all this work? So prior to the game day itself, the SRE team and the engineering team will get together, figure out which system we want to target and what kinds of experiments we want to run. How do we want to break it? Once we've got all the experiments laid out and kind of a board, then we'll start the game day. And we'll go through maybe a dozen experiments over the course of a few hours. And we'll start off by having everybody come up with a hypothesis. What do they think is going to happen when we break, this thing? There's lots of different ways to break things. We can target resources like CPU and memory. We can target network stuff. We can mess with infrastructure, breaking entire things down. So we'll kick off the chaos for the experiment. And then we go over to the observability tools, which are critical for a game day. If you can't observe the chaos, it does no good. So we make note of what we observe. Did things blow up? Did things not blow up? Which things were impacted? Once we feel satisfied with what we observed, we end the experiment. Things are back to normal. And then we reflect. And so if our system handled it just fine, that's awesome. It's certainly not a waste of time. Now we have confidence that our system is reliable under these conditions. If things did catch on fire, what can we do to prevent them from catching on fire next time? How can we make the system more reliable? So we come away with action items. So when we started moving to Kubernetes, it became apparent that we didn't really understand Kubernetes. Our Kubernetes started out as kind of a grassroots effort. A few passionate developers formed a proof of concept. That did well, so we kind of formed a guild around it. But we don't have a dedicated Kubernetes team like we probably should. We just have a few passionate individuals. So in general, we don't understand how it all works. So we thought, this is a great opportunity to learn about it. Let's break Kubernetes. So we used Litmus, an open source tool. You can check it out at litmuschaos.io. It comes with tons of out-of-the-box ways to break Kubernetes in fun and fantastic ways. So we leveraged those, and then we use Sumo logic to observe the chaos. And the event was a huge success. We learned a lot about how Kubernetes worked. We learned how to troubleshoot things. Some things worked great, like self-healing and auto-scaling and the cluster failover. Some things didn't work as great. We had a system that when we started messing with memory, it burst into flames. And when we went to try and figure out why it was bursting into flames, it wasn't really clear. So the team came away with an action item to improve the logging for that system so that it would be easier to troubleshoot in the future. We also had not turned on traces yet. And so we, SRE, came away with an action item to get traces in there using OpenTelemetry, because without the traces, we had really good observability into what was going on in Kubernetes, but not so much with the systems themselves, like the error rate or the response times for the systems. That comes with traces, and those two metrics are critical. So yeah, overall, huge success. Looking forward to doing it again. So optimization is another tool in our toolbox. And in Kubernetes, your systems have to request how many resources they want. In these two charts, we can see for customers of Sumo Logic, some are requesting the right amount of resources for their systems, and some are not. In the yellow, we can see these are systems that are asking for too many resources. And that's a problem because it's a waste of money. In the red, we can see the systems that aren't asking for enough resources. And this can cause all sorts of problems. If a system isn't asking for enough CPU, Kubernetes will throttle it, which can cause problems. If it's not asking for enough memory, Kubernetes will try and help by killing your pods, which will cause your system to get stuck into a loop of constantly restarting, and that can also cause problems. So how do we know what those values should be? There are the global intelligence dashboards, which are super awesome. So they look at the last 8 days worth of data for your system to figure out what they think your values should be. And it'll tell you kind of where you sit currently. In this example, we can see that the flight search service was asking for too much CPU. And so it had a little yellow hexagon. Down below that, there are recommendations based on what you care about. If you care about saving money, then you would go with the cost recommendations. If you don't care about cost and you want that thing rock solid stable, then you would go with the reliability side. Or if you're not really sure, or you just want something in the middle, there's the balance. So you can click on the hexes for whatever you want, drill down into the linked dashboard, and then you get your recommended values. And here we can see that the current is the red bar, the recommended is the green, because we were asking for too much. So for flight search, we went to production with the new flight search experience, but it's not live yet. And what the engineers did is they figured out a clever way to copy all of the traffic to the current experience to the new experience as well. And we left it running for a couple weeks so that we could get a good baseline for the global intelligence dashboards. Then we used the global intelligence dashboards to figure out what should we be requesting for all of this traffic, grab those numbers, threw it in, and now we are confident that when we do go live, we're not going to tip over or burst into flames. So what's funny is that before we used the global intelligence dashboards, we were actually asking for about 40% more CPU than we needed. So we were going to be wasting money. And we were actually asking for 40% less memory than we needed. So we were going to be having a bad day. But now we're going to be good. So to kind of wrap things up, observability is complicated and it's getting more complicated. SLOs are a great way to track reliability, and SLAs are a great way to enable the teams to address issues before they become incidents. And chaos engineering and the global intelligence dashboards are a great way to be proactive and prevent issues from happening. Thank you very much.